And dear all, welcome to this third lecture of unit number 5, power assuring devices. So in this third lecture we are going to see refrigerate part C, that is the refrigerators and air conditioners. So what is meant by refrigerators and air conditioners? So first, that is refrigeration. So actually these are the two different parts. One is the refrigerator and second is the air conditioning or air conditioners. So first we are going to see refrigeration. So refrigeration is the process of achieving and maintaining a temperature below that of the surroundings. So the aim of this being is to cool some products or space to the required temperature. So again we are going to see refrigeration, that is the process of achieving and maintaining temperature. So here this achieving and maintaining a temperature, these are the two important words: maintaining a temperature below that of the surrounding. So and the aim, that is obviously if you maintain temperature below surrounding, that is going to giving us cooling effect to that specified area. So application of this refrigeration, that is also important. So one of the important application of this refrigeration is in, can say, preservation of the food products, obviously by maintaining them at the lowest temperatures, or can say low temperature. So now how this refrigerator or refrigeration works, that we are going to see. So this here, this figure indicating block diagram of refrigerator with different parts. Now we can see here working principle of refrigeration or refrigeration systems. So now refrigerator, this already here, that later this R indicating stands for refrigerator, or you can say refrigeration system. Then here this below is the low temperature reservoir, then upper is the high temperature reservoir. So in this power absorbing devices, we are going to transfer heat from low temperature to the upper at the high temperature. Again you see, so here in this there is heat transfer from a low temperature reservoir, this can say, to the high temperature with the help of some input energy. So here work input we need to supply here to get work done by this refrigerator. So it is the, can say, basic definition of power assuring devices. So to get some work done, you have to supply some work in the different form, another form. So here we are going to supplying work, in that expense you getting here work output, that is the transfer of heat from low temperature to the high temperature. So here this heat going to absorb from this low temperature and you going to reject it to the high temperature. So if you are going to see power producing devices, in that case it is totally reverse. In power assuring devices, heat is transferred from this higher temperature to the lower temperature reservoir, and in that expense you getting work output. So this is the, can say, totally opposite these power producing and absorbing devices. Example of this power producing, that is engine. So engine heat is transferred from higher to the lower, in that expense you getting work, means that crankshaft going to rotating, and that going to utilize to run vehicle. So this is the working principle of refrigeration. Means here you have to supply work input to transfer it from low temperature to the high temperature reservoir. We make first this clear. Now this is here one important term in these refrigerations, that is the can say performance of this refrigeration. So here rating of this refrigerating machine or refrigerator is given by standard unit of refrigeration, that is called tons of refrigeration, that is the short that for application, that is TR. So what is ton of refrigeration? So here we are going to define in terms, that is 1 ton of refrigeration means capacity to freeze 1 ton of water, that is can say here capacity to freeze the 1 ton of water from and at 0 degree Celsius in 24 hours. So in other way, tons of refrigeration means, that is you can say capacity of the refrigerator to freeze 1 ton of water from at 0 degree Celsius in 24 hours, that is called tons of refrigeration. Now types of refrigeration. So there are two types of refrigeration systems. One is the called vapor compression refrigeration system, that is VCR. It is going to use mechanical energy. Second is vapor absorption refrigeration system, that is VAR. It is going to use thermal energy. So here we are going to see first refrigeration system, that is the vapor compression refrigeration system, that is VCR system. So here this is the block diagram of vapor compression refrigeration system. Total it consists 4 parts. First part, that is the here is the can say evaporator, or we start from your compressor. So first part in there, that is the compressor. So this is the first part. Instead of this, okay, we want to use cursor. So this is the first part in this vapor compression refrigeration system, that is the compressor. If you are going to see actual refrigerator, it is the located here. This compressor means in refrigerator at the back side, at the bottom there is one black box, that is called compressor. So here this compressor is coming at the center of this low pressure side and high pressure side, and remaining parts, this condenser, this coming at high pressure side. Again expansion device is coming at the boundary of high pressure side and low pressure side, and evaporator is again at the low pressure side. So first we will see compressor in this cycle. So what is the function of compressor? Okay, so function of compressor is to compress refrigerant. This is the closed cycle of this vapor compression system. So here this is the, we are going to see connections of this compressor. So at the here there is entry of the refrigerant coming from evaporator. It is having low pressure, low temperature, and outlet of this compressor is connected to the condenser. So here we need to pressurize refrigerant which is coming from evaporator having low temperature, low pressure. So that refrigerant going to pressurize here in compressor, and with that high pressure it is going to pass to the condenser. If you are going to see pressure here, it is coming around 0.2 bar entry from evaporator, and it is going to increase pressure up to 8 bar. So increase in pressure in compressor is 0.2 to 0.2 to 8 bar. So that high pressure refrigerant is going to the condenser here. This is the next part of the cycle. So condenser, again it going to here condense that refrigerant, and after condense means it going to cool refrigerant by taking surrounding air. So or sometimes here also going to provide fans, blowers, so that going to again help for the cooling effect of this condenser. So again here pressurized refrigerant means high pressure and high temperature, it again going to cool up to some extent, and that lower temperature refrigerant is passed to the next device, that is expansion device, third part, or you can say capillary tube. So what is the role of this capillary tube, or you can say expansion device? Here actually this is the connection of two pipes, means joint of two pipes having different diameters. So here up to this there is diameter is from this condenser to expansion is lower or small, and here from this expansion device to the evaporator going to increase. So here there is increase in diameter in this expansion device occurs. So because of increase in diameter, again that refrigerant, that pressure going to decrease, temperature also going to decrease, okay. But at the same time velocity of this refrigerant going to increase. Because of increase in diameter, velocity going to increase, so that going to pass to the next device, that is the evaporator. So fourth part of this cycle is the evaporator. So what is the role of evaporator? In this evaporator, whatever heat of the objects that going to absorb, and here we getting cooling effect of the object, because you can say this is the main compartment, heart of this vapor compression different cycle. So and after this again it going to absorbing heat of the objects, and in that expense here temperature going to increase up to some extent, also pressure going to decrease again to some extent. So again then it going to pass to the compressor. So in this way this vapor compression cycle this runs. If you want to see here different parts same, so here this is the compressor at the bottom, then after compressor refrigerant is going to pass to the condenser, this is the condenser, then after condenser here is the dryer, a dryer that going to absorb humidity or can say impurities present in the refrigerant. Then here is the capillary tube or expansion device, they are going to control flow rate of the refrigerant as per requirement, also going to increase the diameter, increase in diameter occurs, so that going to helps to decrease pressure, and then after that last part is the evaporator. This is the evaporator, here heat of the object is going to absorb, and that will help to get cooling effect of that objects. Now here same is there, it is given that vapor compression refrigeration cycle is commonly used in refrigeration and air conditioning. So here we have seen refrigerant. So there are different types of refrigerants like ammonia, NH3, RE11, R12, R22, CFC, that is chlorofluorocarbon, like these different types of refrigerant going to use. Now we are going to see refrigerator. So this is the one application of can say food preservation at the end of this user level. So refrigerator is, you can say, insulated box in which lower temperature is maintained to facilitate medium term storage the food. So here this refrigerator is a insulated box, you can say, like this is the box, insulated box in which low temperature is going to maintain. So here this at the bottom, this green part, that is the compressor which I have seen in vapor compression cycle. After compressor, okay. So here different parts of refrigeration systems, one is the evaporator, compressor, condenser and expansion device. So we are going to see First we are going to start from compressor. So at the bottom there is compressor, then condenser. So these above vertical red lines that I want to show here, it is the condenser. And then there is here at the one location here there is, you can say, change in the diameter, that is the expansion device. Okay, or you can see here this way. So compressor, this part, that is compressor, then condenser, this part U-tubes, that is condenser, then expansion device, joint of having different diameters, that is expansion device, and evaporator, whatever pressure zones, that is nothing but the evaporator. And here same it is there. At the bottom there is still compressor, then these are the condenser lines, then after condenser here there is capillary tube, expansion device, then here pressure cabinet, that is you can say pressure zones. Okay, now we want to see how this refrigerator works.
Basic principle of refrigeration is simple. Just pass a colder liquid continuously around the object which is to be cooled. This will take heat out from the object. The whole refrigeration technology is after this: how to produce cold liquid continuously. We will see how this is achieved in this video. This is what inside a refrigerator. At the heart of the system is a simple device called throttling device. Cold liquid is produced with help of this phenomenon. In this case, throttling device is a capillary tube. For effective throttling, at inlet, refrigerant should be high pressure liquid. Throttling device is an obstruction to the flow, which causes tremendous pressure drop. Due to drop in pressure, boiling point of refrigerant comes down, and it starts evaporating. Heat required for evaporation comes within the refrigerant, so its temperature drops. If you check temperature across throttling device, you can notice this drop. Next phase is simple. Just pass this cold liquid over the body where you have to absorb heat. During heat absorption process, refrigerant further evaporates and transforms into pure vapor. So we have produced the required refrigeration effect. If we can take this low pressure vapor refrigerant to state before throttling process, that is high pressure liquid state, we will be able to repeat this process. So first step, let's raise the pressure. A compressor is introduced for this purpose. Compressor will raise the pressure back to its initial value. But since it is compressing gas, along with pressure, temperature will also raise. It is unavoidable. Now the refrigerant is high pressure vapor. To convert it to liquid state, we are introducing another heat exchanger. This heat exchanger is fitted outside refrigerator, so it will liberate heat to the surroundings. Vapor will get condensed to liquid and temperature will come down to normal level. So the refrigerant is back to its initial state again, high pressure liquid. We can repeat this cycle over and over for continuous refrigeration. This cycle is known as vapor compression cycle. You can note more details of refrigerator components here. To enhance heat transfer, both evaporator and condenser are having fins attached to it. Since evaporator is cooling the surrounding air, It is common that water will get condensed over it, forming frost. Frequent removal of frost is required to enhance heat transfer. Apart from raising pressure, compressor also helps maintain flow in the refrigerant circuit. Usually, hermetically sealed reciprocating type with proper sealing is used for this purpose. Since it is compressing gas, huge amount of input power is required for this operation. A simple energy balance of the system yields this relation. Performance of a refrigeration system can be defined as follows. Hope you had a good overview of working of a refrigerator. Thank you. Basic principle of refrigeration is simple. Just pass a colder liquid continuously around the.
So here we have seen working of refrigerator. Now we're going to move to this second part, that is the air conditioning. Basically, air conditioner also going to work on the same vapor compression refrigeration cycle, that is VCR cycle. Only now we're going to see what is the change in the refrigerator and air conditioning. So air conditioning, that can say it is the control of humidity, air movement and purity of an air in a enclosed space. First we are going to clear all this. So air conditioning is nothing but the control of the humidity, air movement and purity, that is you can say dryness. So here this process is typically applied to maintain level of the personal comfort. As we know, our human body temperature normally the range is the 37 degrees Celsius. So if climate conditions or surrounding conditions temperature going to increase or decrease, that time we are not going to feel comfortness. So to get comfortness, what we are doing, we are going to use air conditioner, that is the AC. So mostly in winter season the temperature going to below, that time we are going to increase temperature to normal condition, but in summer season that going to opposite, surrounding temperature going to increase, so you have to bring it to the normal temperature, that is the around 20 to 25 degrees Celsius. So to get these temperatures we are going to use air conditioners. So this is not only for, you can say, our human perspective or you can say personal comforts, we are also going to use industrial applications, because whatever different machines, CNC machines, computerized machines, that also require temperature range, means temperature comfortness, otherwise they are going to influence performance of that machines. To operate in specific environment conditions, that machine they also require to maintain air conditioning. So there are two types of air conditioners, one is the window air conditioner and second is the split air conditioner. So first we are going to see window air conditioner. So it is a cubicle unit or you can say cubicle device which is going to use here for human comfortness. So you can say it is the window air conditioner. So here it requires window, means this air conditioner is going to fit in window, that means half part of this air conditioner, that is evaporator part, is in the inside window, and remaining parts, that is compressor, condensers, that blowers or fans, these are the located at the outside of the window, that is the outside of the wall. So that is called window air conditioners. So here this again indoor air conditioner consists almost same parts compressor. So here this is the compressor, then condenser. So here these are the condenser coils. So at the back side of this, here these are the condenser coils exposed to the air for cooling effect, and also here there is fan from here inside. So this part nothing but the fan. Then here there is a blower. Now what is the role of the blower? So here again this is the evaporator coil. So at this location inner side there is evaporator coils. So that evaporator coils, evaporator going to release cold air. So that cold air going to spread inside room by using these blowers. So that helps here to spread that air. Now we are going to see how this window air conditioner works. So again it is working on vapor compression refrigeration cycle. So this it is a closed cycle. It consists again refrigerant. So we start from again compressor. So in this compressor refrigerant, we start from this again, okay, compressor. So just we'll see this how it going to works. So here this part is nothing but the compressor. So here from this evaporator low pressure refrigerant is coming. Now we have to compress it. So here in compressor is going to compress, so the pressure going to increase, and that high pressure refrigerant going to pass to the condenser. This part nothing but the condenser. So in condenser it going to giving cooling effect by using this side here fan, and also from outside air it also going to helps for their cooling effect. So here these are the condenser tubes. It going to giving us cooling effect. So after getting cooling effect, it is passed to the next device, that is the capillary tube, or you can say throttle valve. So again in throttle valve there is the change in the diameter of that pipe occurs. So the throttle valve also going to use or control the flow rate of this device, that refrigerant, and through that throttle valve it come into the evaporator. So this is the evaporator. So here in evaporator it going to spread that cold air with the help of this blower in the room area, and that helps to get cooling effect in the room area. Here there is also filter is also used, so that whatever impurities inside that room, that air that going to trap, and only fresh air that going to pass to the room. So now it also works on the thermostat principle. What does mean by thermostat principle? Means when you going to set temperature of room, suppose 25 degrees Celsius and surrounding temperature is 40 degrees Celsius, that time to get temperature up to 25 degrees Celsius, that refrigerator going to work, means compressor going to work, and once it going to attaining that temperature, it going to stop. Again when there is deviation in temperature, maybe because of opening of door or any other reasons, that again going to start their functioning. So that temperature going to maintain 25 degrees Celsius by automatically by using thermostat. So that is the role of, can say, thermostat. Now here you can see effect of these two. So here heat is transferred from air to the evaporator coils for evaporation refrigeration principle, and at the other side here that heat going refrigerant that going to transfer heat to the surrounding. So surrounding air going to heat. So here you can see output of this cool air going to out, means inside the room area, and warm air, hot air going to out because of this fan or because of coming contact with the condenser tubes. So So in this way this window air conditioner works. This is the same figure of this. Here this is the evaporator, means you can say this is the wall. Okay, so this is the wall area, means this evaporator is here, this is the inside this wall, and remaining parts, this is the compressor, then condenser tubes, then this fan, a blower. These are the located outside the window or wall, and this located inside, so it is called window air conditioner. This is also one same that figure. So here this compressor will going to compress refrigerant, it coming is going to give the condenser, that is here in condenser it going to again cool refrigerant. So whatever warm air coming contact with the condenser tubes, it becomes, because of this cool air becomes, or they are going to transfer here. Then next is after that coming to the expansion device. Again here there is decrease in the temperature and pressure, then it coming to the evaporator. So in evaporator, whatever air coming from a room, that going to again cool, and they are going to again recirculated till to getting required temperatures. Again it after that going to pass to the compressor. In this way this cycle going to works. Now second type of air conditioner, that is the split air conditioners. Now mostly we are going to use split air conditioner. Split air conditioner means there is only one part evaporator is the inside room area, the remaining part, that is the condenser and all these devices that are going to enclose in the cabinet, outdoor unit, that is called split air conditioners. So here in this means indoor unit, upper is the indoor unit evaporator and lower is the outdoor unit. So indoor unit consists front panel, air inlet, air filter, air outlet, horizontal air grill, display panel. The outdoor it consists connecting pipe, cable, then stop valve. Then application of refrigeration systems, refrigeration air conditioning system. So now till now we have studied this, but now we are going to use. So this refrigeration system also used in vehicles. If you are going to see vehicle bonnet, below that there is condenser for cooling effect. Then there is also one compressor, means same that cycle going to work here, compressor evaporator automobile system. Also in industries for can say food reservations, packing, that air conditioner system is going to use. This again split air conditioner. So we are going to have finish unit number 5. So all are expected here to go through these videos